This lesson is about voltage calculations, and it follows on from the previous lesson on voltage. In this lesson, we're going to look at how voltage interacts with the concepts of current and charge. Remember to pause the video and have a go at each question before I go through it together. So, in this question, we need to calculate how much energy is transferred when 8 coulombs of charge flow through a potential difference of 3 volts. So I know that voltage is equal to energy divided by charge. Here I'm just using the symbols. Voltage in this case is 3 volts. Energy we don't know, so we'll leave it as E. And our charge is 8 coulombs. Now I just need to solve for E, or energy. And to do so, I'm going to multiply both sides by 8 coulombs. So 3 volts times 8 coulombs is equal to a certain amount of energy. And I know that that is equal to, if I use my calculator, 24 joules. Hopefully you got that right. If you didn't, hopefully these steps have made it clear. Let's try another one. Pause the video and have a go first, and then we'll go through it together. In this case, 150 joules of energy is transferred when 50 coulombs of charge flow through a wire. Calculate the potential difference of the wire. Remember, potential difference is also known as voltage. So your first step should have been to write the equation. And your second step should be to substitute into the equation. Voltage, we don't know. We're going to leave that as V. Our energy is 150 joules. Oops. And our charge is 50 coulombs. We can put that into our calculator. We can find that voltage is equal to 3 volts. That's it. Now let's try a few more difficult ones. These questions are going to relate current and voltage. So here we have a circuit. It's switched on and charge flows through a bulb. Afterwards, the current in the circuit is doubled and it's switched on for 3 times as long. Explain the change in the amount of charge that flows through the circuit. Pause the video and have a go first. So for this question, we need to recall what current is. Current is the rate of flow of charge. It's a measure of how much charge flows in a certain amount of time. So current is equal to charge divided by time. In this case, our current is doubled and our time is tripled. So the overall impact on charge, when I rearrange this, this is twice as large and this is 3 times as large. So the impact on charge is 6 times greater. So as we know, 2 times 3 equals 6. Let's try one more. Now the potential difference of the battery is doubled. What happens to the charge flowing through the circuit? Now remember, potential difference is voltage, and that's doubled. What happens to the charge flowing through the circuit? Really think about it. Look back at your equation, pause the video and have a go. Now, as you know, voltage is equal to energy divided by charge. We can recall our understanding of what 1 volt is. 1 volt is when 1 joule of energy is transferred to 1 coulomb. So in this case, as the potential difference is doubled, now each coulomb of charge transfers twice as much energy. And that's it. Let's try one more calculation. Read the question, pause it, follow the steps, and have a go yourself. In this question, the label on a 12-volt car battery, that's our voltage, says that it will provide a current of 44 amps for 1 hour. So we're given voltage, current, and time. Calculate the charge and the potential energy stored in the battery. Now we have two equations that we know. One is that current is equal to charge divided by time. Now other equation is that voltage is equal to energy divided by charge. So the first one we're going to use is this one here. We're going to use that equation because we know what current is and we know what time is. We have 44 here and we have 1 hour here. We wouldn't be able to use this equation because we don't have a value for energy. So we wouldn't be able to find charge although we have voltage. So in this one, we're going to now substitute into this equation. Current is equal to 44 amps. Our charge is unknown, so I'm going to call that Q, and our time is 1 hour. The problem with this is we now need to convert 1 hour into seconds. This is where most people trip up on this question. 1 hour is equal to 60 minutes. And each minute has 60 seconds. So that's 60 times 60, which is equal to 3,600 seconds. So 1 hour is equal to 3,600 seconds. So 1 hour is equal to 3,600 seconds. I can now rearrange to find Q. Right now, I'm multiplying both sides by 3,600 seconds. Now all I need to do is put this into my calculator and I get an answer of 158,400 coulombs. And that's my value for charge. Now I'm going to look at the second part of this question. So I've found charge. Now I need to find energy. I know what voltage is, I know what charge is, so now I can find energy. My value for voltage is 12 volts. Energy is unknown, I'm going to leave that as E. And my charge is 158,400 coulombs. Now, in order to find energy, I'm going to multiply both sides by 158,400. Remember, we calculated charge here, and I'm simply using that same value for charge here, because the charge remains the same. It's the same battery. It's the same question. So Now my value for energy is equal to 1.9,800,000 joules. And that's my final answer. I hope this lesson has been useful. If you have any questions, please do ask.